So here's the thing. We're gonna pretend that I'm gonna wake up for a normal day of school. We're gonna pretend that I'm not waking up at noon like most of you are doing. We're gonna pretend that I'm gonna go do my job at the regular time that I'm gonna do a job. Well, what do I have to do? I've gotta wake up. I've gotta get cleaned up. I've gotta get ready for school. Which one to choose? So many ties. I'm expected to wear pants to work, at least when we're back in school. How many of you are sitting at home, doing your math homework? I don't want to know what you're wearing. Never mind. There's the idea of the genius outfit. Steve Jobs, Mark Zuckerberg, Albert Einstein. The idea is that they wear the same thing every single day. Mr. Rogers. And what's nice about that is that they wake up, they put on their clothes. That's it. Now, for the rest of us, I really don't know why I just threw everything onto the floor. Now I've got to go put it back in order. How many of us have our closets in chromatographic order? You know, in order of color, like the rainbow. You put all the blues together so you know where all the blue shirts are. You put all the whites together so you know where all the white shirts are. You put the white things with the white things. Gray shirts together. Slightly off from the black shirts, in between the white shirts, because that's just where things go. But for those of us that have to wake up and get dressed, you need to figure out what to do. I've got a system. You may not have noticed, but when we were together for our month, 2 months, up until the time that we've gone on Coronacation, I had the same order to my shirts every single time. I don't know if you noticed. Were you actually paying attention? Does anybody pay attention to me? Second semester, senior year? Yeah, I know how it is. But I have a specific order to go through things. So I would actually always go through the same cycle of shirts. You know, there's the white shirts. There's the blue shirts. There's a different blue shirt. There's a different blue shirt. There's a different blue shirt. I kind of like that blue on this camera. Looks different. That's a good camera there. But as I would go through, if you were paying attention, gone over that already. There's also the pants that I would cycle through. And I've been doing this for a little bit of time. This is one of those, as soon as it's done, I'm walking down to Dr. Bean's office, down to the principal's office, I'm saying, I'm out. Problem solved. I'm done with this. No more. And it's not because I'm not going to enjoy my job. It's because what you haven't noticed, and we didn't get the chance this year, I've never repeated a tie yet this year. Actually, I go through the entire year, typically lasting up until mid-March, which I can actually say that I have not repeated a single tie, bow tie at all this year. But my scheme, my organization, is I go through the pants. Then I go through the shirts. Now I have to wear some pants every day. I've got to wear a shirt every day. And I wear a tie every single day, except for Fridays. Look at all those ties. Now what I want to get at is here, I have it planned such that I have actually never repeated an outfit ever in all my time here at school. What I do is every single day, change my pants. You're supposed to change your pants. I wear a different shirt and I put on a tie. Now the way it works out though, is not that I'm never going to repeat a shirt. I'm not going to go for 37 and a half years wearing this different shirts. It gets expensive. But what I do, got a shirt, got a pair of pants, got a tie. Nobody has ever seen me wear this combination. The number of shirts that I've got, the number of pairs of pants that I've got, going through in order, cycling through my ties. Here's what I do. Every day, it's a different one. Every single day. Every Tuesday, it's a different bow tie. I cycle through and put it back on a loop. And what happens is that when I cycle through, it's so much that it never actually repeats. How long? Oh, we're getting into math. How long can I go until I repeat an outfit? Now we're going to assume that I'm going to wear pants to school. We're going to assume that I'm going to wear a shirt to school. We're going to assume that it's either a tie day or no tie day. How long can I go without repeating an outfit? And at that time, that's when I'm calling it quits. Dr. Bean, I'm out of here. All right, so to figure out this problem, here's what we have to do. We are taking advantage of something that's known as the counting principle. And that's what we're going to start looking at. How do we count a total number of possibilities out there? Be it the total number of ice cream flavors, be it the total number of different combinations you can have on your Moe's home wrecker. When you get chicken, you get beef, you get vegan tofu, whatever you want to call that. All comes down to the counting principle. Now, the idea behind the counting principle is going to be a way to determine the total number of outcomes when combining one element each from separate sets. It's going to be the total number of outcomes is the product multiplication of the number of elements in each set. Now, just kind of a little bit of clarification. One element each from separate sets. Now, when we're talking about my school outfits, I'm going to wear a pair of pants. That's one set. How many pairs of pants do I have? I am going to wear one shirt. So the shirts are a different set of elements. I'm going to wear one of those shirts. I'm going to have a tie, a bow tie, or not wear anything. So my neckwear is a different set of elements, and so I'm going to pick one of those. We're going to multiply to get the total number of elements, possible outcomes. We're going to multiply the number of elements in each set to get the total number of possibilities. So let's consider my closet, my choice of clothes for school, because that's what I care about. So I do have 7 different pairs of pants that I choose to wear one pair at a time. Wearing 2 pairs of pants doesn't exactly work out, so I'm going to pick one pair of pants to wear at a time. I have 15 different shirts from which I choose to wear one shirt at a time. And I have 52 ties, 21 bow ties, and I pick one of those to wear each day, or I choose to not wear one of those each day. So based upon this counting principle, how long can I go without repeating an outfit? And you can kind of guess at this point. Is he serious? Is he joking? Yeah, when I started teaching 14 years ago, I figured things out. This is the number of shirts that I have. This is the number. Now, I get a new shirt, I get rid of an old shirt, that kind of thing. So let's start off with a quick example. Let's say I have one pair of pants, one shirt, one tie. How many different options do I have? Well, I can only wear that one pair of pants, one shirt, one tie. I'm going to multiply. One shirt, one pants, one tie. I have one total outfit. If I have one pair of pants, one shirt, and 2 ties, well, I could do pants number 1, shirt number 1, tie number 1. I could do pants number 1, shirt number 1, tie number 2. I've got 2 total outfits. This is exactly the same as the multiplication principle back to probability earlier this week. If we are rolling 2 dice, well, we have 6 options. We have 6 options. We have 36 total options. We are multiplying those individual pieces. So we could keep going on this, looking at how it branches out, thinking back to a tree diagram to see all of the different possible outcomes, the possible combinations. But let's go through. We're going to multiply the number of pants, the number of shirts, and the number of neckwear options. So let's pay attention to me. I have 7 pants. I have 15 shirts. I have 52 different ties, 21 bow ties, and the option to wear neither. That's usually the Friday option. So that's a total of 64 different pieces of neckwear that I can go with. That gives us 6,720 unique different outfits. We take the number from this set, multiplied by the number from this set, multiplied by the number for this set. We want to combine, we multiply the number of elements all together. Quite a bit. Well, how much is that? It's really not that many. If you think about it, it multiplies up pretty quickly. But the real question that I care about, how long am I going to be teaching? I've got 6,720 unique outfits. I have made a vow that I will wear one a day and never repeat. I managed to go most of the year without repeating a tie, so it's just cycling through. It's 180 days every school year, we'll say. If I divide, that actually gives me 37 1/3 years of school. I actually planned this. This is no joke, no true story here. I planned this out when I first started 14 years ago. So 14 years ago, my very first year teaching, it's like, okay, I gotta have this many, this many, this many. I like my ties. People actually kind of give me ties, so I make it work. Now, full retirements at 37 and a half years, maybe that last 0.2 year, that last month, I'll show up. Do I really care about my outfit at that time? I'll make it work. Stick it out for full retirement. Anyways, I've got 14 years down. That leaves me with 23 and a half years to go. So, what I want you to do, I want you to remember this. Put this in your calendar. This is like your final exam in 23 and a half years. So, January 2043, you stop by school once again. Say, hey, Mr. Lyston, remember me all those years? I'm going to be a little bit older. I'll be in my 40s by that time. I'm going to be like, nope, time to go. Let's go see Dr. Bean. Time to peace out. That's how we do it. All right, thanks. Now you try it.